So, in engineering economics, under second unit, value engineering, today we will see the topic on uniform gradient series, annual equivalent factor, and effective interest rate. Okay, so I'm going to use the prescribed textbook given in the syllabus, Pandit Selvam R, Engineering Economics. So let's move on to the topic. So first one, let's see about the uniform gradient series, annual equivalent amount. Okay, so to understand the gradient series, uh, it is something like the series of an annual payment in which each payment is greater than the previous one. Right, by adding some constant amount. Say constant amount means like an equal increment. So here, if you see the cash flow diagram, then in the first year, the person is depositing a certain amount that is called as an A1. Okay, so amount A1 the person has deposited. And the second year, he has added some extra amount, like amount G. That is which is which is an extra amount than the previous one, right? And the third year, he's adding up extra. And fourth year, an extra, and it goes on till the tenure period of time. So they have given the formula to compute the amount under this kind of a situation. So that is A is equal to A1 plus G into 1 plus I power n minus I into n minus 1 divided by I into 1 plus I into power n minus 1. Okay. And from this formula, we can able to arrive the uniform gradient series factor. So the uniform gradient series factors, which is given in the formula, are A by G. That is A by G ratio. Okay, so I and N. Okay, so let's move on to the problem. A person is planning for his retired life. He has 10 more years of service. He'd like to deposit 20% of his salary, which is rupees 4,000 at the end of the first year. And thereafter, he wished to deposit the amount with an annual increase of 500 for the next 9 years with the interest rate of 15%. Find the total amount of the end of the 10th year of the above series. Okay. So if you see clearly, it is given that the person is going to retire after 10 years. So he's wanting to have some kind of a deposit, right? The deposit is 20% from his salary. So which is 4,000. So he's going to deposit 4,000. So the 4,000 is your initial amount which he's going to pay. That is your A1. And the and also that he wished to deposit an extra amount as an annual increase of rupees 500 for the next 9 years. So this is the increment, annual increment, right? So we have 500 rupees. So 500 rupees is your G value. And also the rate of interest is given as a 15%. Okay, it's a 15% is your I. And yen is your 10. Because he's going to deposit for 9 years. Okay, so finally that he will get it on the 10th year, right? So find the total amount of the end of the 10th year of the above series. So 10th year, so that's what you have yen. Okay, so now we are supposed to find the amount and the future sum. So here you can understand the chart that the first year he's depositing 4,000 and then the 4,000 plus 500 and 4,000 plus 1,000. So it is just gradually increasing till the 10th year. Okay. So with the interest rate of 15%. Okay. So you can substitute in the given formula and arrive the result. Okay. And this is equivalent to paying an equivalent amount of here they have arrived 5,691 rupees 65 at the end of the every year for the next 10 years. So the future sum of this revised series at the end of the 10th year, you can use the formula that is F is equal to A into F by A I and N. Okay, so that it is F by A series. So we have this the amount and then the F by A ratio. So get the F by ratio in the previous problems, which I have already mentioned you some problems. I have already taught you where the F by A ratio comes, right? So check out the same problem. So, and then you can carry over the finding the factors. Okay, so you can use these factors F by A, I, N factor. So this factor is your equal payment series compound amount factor. I hope you remember F by A, comma I, comma N. If you don't, then you please search on the previous class notes. Okay, and substitute the formula, and you can get the value, and thereby you will get the amount at the end of the 10th year, which is compounded annually of all its payment. Okay. And here another problem. A person is planning for his retired life. He has 10 more years of service. He would like to deposit 8,000 at the end of the first year, and then thereby he wishes to deposit an amount with an annual decrease of 500 of 9 years. So first he is depositing 8,500 and then he's reducing it, decreasing of 500 the next 9 years with an interest rate of 15%. Now we are supposed to find the total amount he get it at the end of the 10 year. Okay. So here they have mentioned it as a decrease. So you can proceed with the same kind of uh, procedure as mentioned earlier. But all here given is a decrease of 500. So you can take it as a G. Is a minus 500 rupees. Okay. So you are supposed to have 8,500 first 10 and then 8,500 minus 500, right? 8,500 minus 500 and like that minus 1,000, and it goes on, right, till the year of 10. Now you can substitute the value in the same given formula, and then again substitute the you're knowing the factor. This is an equal payment series compound amount factor is given here. So use it and find the value of F. The F is your single future amount, right? So you will get the future amount. Okay. So same way, if you check out here, so a person is planning for his retired life. He has 10 more years of service. He would like to deposit 20% of his salary, which is rupees 10,000 at the end of the first year, and thereafter he wished to deposit the same amount 10,000 with an annual increase of 2,000 for the next 9 years. With the interest rate of 20%, find the total amount at the end of 10th year of the above series. So here they have given that the person is going to retire and he's having 10 more years of service, and he'd like to deposit 20% of his salary, which is rupees 10,000. Right. So the first year he's depositing the 10,000, and thereafter he deposits with the increment of 2,000 for the next year. So first one will be your first deposit will be your 10,000, and the second deposit will be 10,000 plus 2,000. So likewise, plus other 2,000, another 2,000, another 2,000, right? So it goes on till the 9 years. Okay, so that is 10,000 plus 2,000, 10,000 plus 4,000, right? So you can verify the same problem which I have explained in the example problem, and you can carry over this problem. Okay. Okay. And 16th question. So a person is planning for his retired life. He has 10 more years of his service. He'd like to deposit rupees 30,000 at the end of first year, and thereafter he wished to deposit the same amount, 30,000, with an annual decrease of rupees 2,000 for the next 9 years. With an interest rate of 18%, find the total amount of the end of 10th year of the above series. So it is also the same thing which is given in the previously explained example problem, the second one. So that is he's going to retire at the 10 years later. Okay. So he wished to deposit 30,000 at the end of the first year, and then he's going to decrease the amount of 2,000, right? So decreasing means that my G will be minus 2,000, right? So minus 2,000 minus 4,000, and it goes on, right? So for the next 9 years, and also the interest rate is also given. So now you're supposed to find the total amount at the end of 10th year of the above series. Okay, so try to solve this problem also. And the 14th problem. Consider the following cash flow diagram. Find the total amount at the end of the 10th year at the interest rate of 12% compounded annually. So 8,000, 8,000 plus 1,000, 8,000 plus 2,000, 8,000 plus 3,000, right? So here they have given the flow chart directly, and they have asked you to find it at the end of the 10th year. Okay, which is of interest rate of 12%. Okay, so and you can solve the problem. And again, you can also verify the another problems which uh, which is given here. And if you have any doubt, then you can either mail me or else put it in Google Classroom, or you can WhatsApp me, and I shall clear you the doubts. Okay. So let us move on to the second one. So that is effective interest rate. So the effective interest rate is knowing that in this that it is saying that you knowing about the loan amount, about loaning or whatever, maybe we are supposed to do it either monthly, quarterly, or else semi annually, or else annually, so the interest rate, but not the annually, sorry, but that would be in a particular period of a time. Okay, so mostly each and every month they will give you some kind of interest, right? So here, so let us assume that I be the normal interest rate compounded annually, but in practice the compound may occur less than a year. For example, compounding may be monthly, quarterly, or semi-annually. Okay, so and the compounding monthly means that each and every year there will be some interest, and there are 12 interest period in a year if the interest is compounded monthly. If it is compounded annually, means that at the end of the year you will have it. Okay, monthly means that every month, or as a quarterly, or as a half yearly, they'll give you some kind of interest rate. Okay, so under such situation that you can use this effective interest rate to calculate the things. Okay, so here the interest rate they have given you as in the formula. So that is effective interest rate is R. It's R equal to, it is I plus I by C whole power C minus 1. Okay, so I think there is a mistake here. So it's not B plus I by C G minus 1. It's not that. So that is 1 plus. You please refer the, if you're not having the, well, sorry. Okay, I'm just typing here. You just please check and change it. So that is effective rate of interest R is equal to 1 plus I divided by C power C minus 1. Okay. So that's the formula. I hope it's yeah. I hope that it is clear with the formula now, right? So R is the effective rate, interest rate, and I is I mean the interest rate, and the C is a number of interest period in a year, right? So kindly use this formula. Okay. So moving on to the question. A person invests a sum of 5,000 in a bank at a nominal interest rate of 12% for 10 years. The compounding is quarterly. Find the maturity amount of the deposit after 10 years. So he's having a principal amount. So principal amount is 5,000 here. For tenure is 10 years, so that is your period. N is a 10 years, and the interest rate is 12%, right? So which is a normal nominal interest rate. So with this, first you can find the simply what you can do is that you can use the future sum. Future sum means the time value money. So this formula I mean, yeah. So here they have given you, either you can just directly have a interest rate is there, right? So you can just directly use it and find it out, right? So that is a P into 1 plus I power n. Okay, so the n is your number of quarters. There is a revised number of quarters, capital N. So that will be, that is the interest period is of 4 years. So there is interest period per year will be a 4 times. So 4 times you are supposed to pay the interest, right? So because it is given, there is a compounding is quarterly, right? So quarterly means quarterly, half yearly. So another 2 times, right? So that is your 4. So for 10 years means, then for 1 year 4 times means, then 10 years 10 into 4, that is your 40. That is your revised number of periods. So you have to get the number of quarters, how much total revised period. So that will be a 40 by calculating it, and also that interest rate per quarter. So don't simply take the 12% and all other things directly, okay? So here R is equal to 12%, okay? So 12% means 12%. Again, 1 year, 4 times, right? So here we are having, so 12% divided by 4, totally 3% compounded quarterly. So for quarter period, we are having only 3% of interest. So with that, now you can directly apply with the formula F is equal to P into 1 plus R power N. So in generally that it is already mentioned in the time value of money to get the future worth. Okay, so verify that. So in that they have given you with this, I mean with a regular amount of interest and period, okay? So they have revised it and they have changed it from the quarter to annual rate. Okay, so and they have revised it up, right? So here so you're having that F is equal to P is your principal. So principal is 5,000 and 1 plus R is your quarter period of a time. Okay, means that is everything is converted. Okay, so for the quarter period of a time you have taken, and then total number of quarters you're going to deposit for the maximum period, that is for 10 time for 10 years, so that is your 40. Okay, so you are supposed to convert it, okay, so towards your desired question. Okay, so just convert it and find the value. This is one of the method where you were no need of using any kind of simply you can convert and you can do it. That's your first method. And second method, you can use the formula 1 plus I by C whole power C minus 1. So you can use it. So here they have given you interest. So quarterly means, again you're knowing the number of interest paid per year is 4 times, and the effective rate R will be 1 plus I by C power C minus 1. So C we knowing that is 4, and I it is given that is a 12%. So directly you can apply and get the percentage of the compounded annually. And again you can use it for finding the effective interest rate, right? So both the method will be almost same, but the very minimum differences is there. Okay, so you can use any of the one in these two. Okay, but the main important thing is that read the question whether that is asked for quarterly, half yearly, or what they have given you. Definitely not annually. Okay, so just read that how much they have asked you for, and then convert it and proceed the problem accordingly, right? So a person invests a sum of 50,000 in a bank at a nominal interest rate of 18% for 15 years. Compounding is monthly. Find the maturity amount after 15 years. Okay, so here they have given you monthly. Okay, so monthly means 12 times, right? So number of interest per year will be 12. And they have given you number of interest period is 15. So 15 into 12, 180. So your capital N, the number of quarters will be 180. Right? And the interest rate per quarter R will be 18 divided by 12. Right? and then you can proceed with the same formula if you are following with the method 1. If you're following with the method 2, then the total number of period per year is a C, that is a 12, right? And also you're knowing the interest rate, that is 15, and you can directly use with the formulas and find it out. Okay, but I request you, when you solve for practice, do with the two methods. Okay, so if you have any doubt or any clarification, either you just mail me, or else post it in Google Classroom or in group WhatsApp. Okay, so that is your end of second unit. So in the next class, we'll move on to the third unit. Okay.